Number 7, we have x squared minus 9 is equal to 4x. So what would I have to do first before I use the quadratic? Here. We have x squared minus 4x minus 9 will equal 0. All right, identify our a, b, and c. What is my a equal? Very good. My b? And my c. Tell me what to write then for the quadratic equation.
4 plus or minus square root of negative 4 squared minus 4 times 1 times negative 9.
Good.
2 times 1.
What did you say?
2 times 1.
Very good. All over 2. I'm just going to write 2. This is 2 times 1. Kayla?
Why did the 4 become positive instead of negative?
Because the equation is opposite of b plus or minus square roots of b squared minus 4ac all over 2a. So because it's the negative b or the opposite of b, you take the opposite sign. You could write down negative, negative, but
So if it was a positive, then it would be a negative.
yes, exactly. Okay. All right, what's going to be underneath the radical? So negative 4 squared minus 4 times 1 times negative 9. I think I heard it. 52, very good. So we're going to have 4 plus or minus the square root of 52 over 2. 52 is not a perfect square, so what do I need to do to 52? Yeah, we're going to do the tree. Go ahead and do the tree on your own and then tell me what you get. And actually try it. Don't wait on other people to answer it. Some of you guys are not doing very well on reducing radicals. We need all practice. I'll let everybody finish. And then I'll have you say it. Very good. 2 square root of 13. Any questions on 2 square root of 13?
So why don't you multiply as you did the other one, like before this?
Multiply what?
Because you only have one pair of 2.
You're talking about when you actually reduce it, like what you
Yeah.
say. So if you were to do square root of 52, what does that break down to?
What was it? 4 and 13.
So then-
And then when we did that like a couple times ago, we just had to multiply like the 2 by something.
Because you had 2 pairs of something. We had a pair of 2s and a pair of 3s.
Oh, okay.
So in that case, you multiply it.
Okay.
We have 1 pair and 1 left over, so they just say 2 squared root of 13. I understand what you're saying now. All right, now how do I reduce this fraction? Thank you. How do I reduce it? Kayla, what's your thought?
I'm thinking that we add 4 to the 2 and we keep the square root there because we can really not do anything with that.
Let's not do that. I appreciate what you said, but let's not do that because the square root of 13 makes it so you can't mix those numbers together. But we do have 4 over 2, and we also have 2 square root of 13 over 2. So what can you take out? The 2, yeah. So if I take a 2 out of each of these, because remember you really have 2 fractions going on. 4 divided by 2 is 2 square root of 13 divided by 2.
Square root of 13.
When you have a situation like this, where you have something underneath the radical, we're not going to put the decimals. I would like you to write it separately so you don't get confused.
Why would the denominator be 2? Because isn't it 2, isn't it like 2b? Wouldn't it be negative 8?
It's 2a on the bottom. So 2
Oh, okay.
Alright, so 2 plus the square root of 13. We also have 2 minus the square root of 13. You could figure out the decimal, and for some purposes you need to. But for our purposes, this would be the exact answer.
Why can't you just keep that as 2 plus or minus 13?
Because every time I do that, students get confused, and I found if I make you separate it, then it goes smoother. That says minus square root of 13. I feel like it doesn't look like minus square root of 13. Separate. Everybody ready for number 9? Alright.
I have a question.
Yeah.
I missed what you did with the 4. Where'd that go?
The 4 divided by 2 gives us 2.
Oh, that's 2. That was the one next to the square root of 13.
You do it to both. Because you have addition and subtraction in the middle of those, you can separate those fractions.
Okay.
And just go on a bit of a tangent that might help you understand. Alright, number 9, what do I have to do first? Very good. So we would get negative 8x squared plus 3 is equal to 0. Now what's my a equal? My b and my c.
Oh, so there is a
There you get to see it. Alright, what is my quadratic equation for this one?
Isn't the entire answer just 0? So it's,
You would think. Let's work it out. We'll see what happens.
oh, plus or minus. Okay, yeah.
So just plus minus square root of
0 squared, right? But that minus sign is important. So if you left out the 0 squared, which is fine, don't forget that negative. Go ahead, what did you say, Kayla?
No, there's
It's 0. That's why she jumped right to plus or minus. No, you're fine. Please ask those questions. You could write 0 plus or minus.
That's just weird.
All over. 2 times negative 8. Alright, what do we get underneath the radical?
Negative 16.
Negative 16?
I'm thinking underneath.
Oh, underneath the fraction is negative
Yeah.
16. In the radical, how else to say that? You're right, though.
Interact.
In the radical, we'll say that. I like that.
Do we have to put a parenthesis around the 0 since it's
I leave it out. But remember, the 4 is negative.
yeah. So now I have to put minus 6. I got a 0.
You got a 0?
Yeah. I did 0 squared.
We have plus or minus 4 square root of 6. Still over negative 16. Alright, now we still have to simplify it. So what would I simplify it to? Yeah, this 4 over 16 can reduce. So I can take a 4 out of each. So you have plus or minus the square root of 6 over, would be negative 4, but that's kind of weird to have plus or minus up here. So it's really plus or minus the square root of 6 over 4. Because the minus on the bottom just switches the positive to negative and the negative to positive, so you still have plus or minus. So everybody understand that? Makes sense of it in your head? We could write that one separate, but it looks so similar to what we have been doing. I think everybody understands that you have square root of 6 over 4, or negative square root of 6 over 4. Alright, any questions on that one? Number 11. We'll finally get into an imaginary. Alright, number 11 is already in standard form, so we can go right to identifying our A, B, and C. What is my A value? -3. Good. What's my B value? Good. And my C. Good. Alright, what would my quadratic be then? Divided by 2 times -3. And on your own, go ahead and figure out what is going to be in the radical. That's a better way to say it. In the radical.
So do I have to put a squared in a parentheses?
No, because it's positive, it'll come out correctly. What'd you get?
-5,276.
Luckily, no.
And then I got, oh, wait a minute. Now I got -20.
-20 is right. Everybody get -20? Alright, go ahead and simplify -20. Did everybody get that? 2i square root of 5? If you think about the graph of this equation, what would be true about it if our solutions are imaginary? What's that? Actually, isn't too wonky. What are we talking about? When does imaginary come into place with graphing?
We're doing graphing.
Back when we did graphing. I'll let you think about that for a moment. What is all this reduced to? Emily?
So with the I being there, would you do like 2 times
That would be I squared. Since it's I, it's just going to remain imaginary.
Oh, that's really.
I know what you're typing about.
Could
Okay.
you take 2 out of everything?
Very good. Take a 2 out of everything, so -8 divided by 2. Actually, let's take a -2 out of it. I'm going to go ahead and make this 4. So we said plus or minus.
I. Square root of 5. Over 3.
We divided by a negative, which is why that 4 became positive. Because the numerator is negative and the denominator is negative. So it becomes 4 plus or minus I squared of 5 over 3. Did everybody catch all that? Okay. So these answers are imaginary, and if you think back to when we talked about graphing, where the graph crossed the x-axis is what your solutions were. Where if the graph never crosses the x-axis, that's when the imaginary comes in. Remember that conversation many weeks ago? Feels like many weeks